Okay, let's look at problem 17.2, 17.3, and kind of just kind of go over again the major ideas of this chapter. So, looking at 17.2, they say find the equation of a line passing through the point -1, 2 and making an angle of 13 degrees with the x-axis. And there's two of those. So first you got to draw the picture. So there's the point -1, 2. I want to make an angle of 13 degrees to the x-axis. You can draw two lines like that. It looks kind of like it is an isosceles triangle. So that's the idea. Okay, goes through -1, 2, 13 degrees. So to find there's two lines, obviously. To find the slope, well, we have a point, and to find a line we need another slope, or we need this point where it hits, but I have no idea where that point hits or where this point hits. All I know is that angle is 13 degrees. We could find that out if we really wanted to, but the easy way to do this is, if you know an angle is 13 degrees, then the ratio of the opposite side of the angle, which you always, first off, as much as possible, make right triangles, because we know how to deal with right triangles. There's Pythagorean theorems, and then there's a trigonometric relations, which is what this chapter is about. So I'm going to make a right triangle by dropping a line down there. Now we have a right triangle. We have two right triangles, right? And they're the same, but one goes down, one goes up. Okay, so the slope is the opposite, the y here, divided by the x, right? That's the definition. Change in y divided by change in x. Well, it turns out that the tangent function, so tangent of 13 degrees, by definition, tangent is the ratio in a right triangle of the opposite side, opposite to the angle. Right here is 13, it's the side opposite the angle. So opposite to the adjacent, which is the side next to the angle. So that's what they call it, the adjacent. Now this side is next to the angle too, right? But it's special, it's the hypotenuse. So this is hypotenuse, it's got a special name, right? It's the long side. And then there's the adjacent, because it's next to the angle we're talking about, and then the one opposite. So they all have names. And it turns out in this case that, in all cases, that's y over x, which is the slope. So in a sense, if you find the tangent to the angle, you have the slope. Now, here the slope is positive, and here the tangent of 13 degrees is still tangent of 13 degrees, right? But the slope is clearly negative, and that's because, as we go over, y is still positive, but our change in x is negative, right? We go from positive x to negative x, or smaller number. So it will have the same number, the slope is the same number, but since the adjacent is negative here, we get a negative slope. Okay, so all we got to do is take the tangent of 13 degrees. Make sure your calculator here is in degree mode. So I go tangent of 13 degrees, I get 0.230868. How far do you want to go? I'm just going to go 23. So let's say the slope then is 0.23. Okay, we have a point and a slope. One of them is negative, one's positive. So then we just go y minus y1 equals mx minus x1. Our point is -1, 2, y is 2. Y minus 2 is equal to 0.23 x minus -1. Okay, so what's that? Y is equal to 0.23x, that's plus 1 minus a point, plus 1 times 0.23, so plus 0.23 plus 2, or y is equal to 0.23x plus 2.23. I think that looks right. Okay, there's one of the lines, and then the other line, we just use negative 0.23. So we just use the slope is negative 0.23. And I'll let you guys do that one on your own. Part B is basically the same thing, but they say equation line make an angle of 8 degrees with the y-axis and passing through the point 1, 1. So just draw the picture as carefully as possible. Try to draw it to scale. Kind of helps, even though my angle here probably isn't 13 degrees, it's bigger than that, but still try to draw the pictures to scale as much as possible, and that really helps. Okay, so the point here is that tangent is defined to be the opposite side over the adjacent side, opposite over adjacent, which is the slope, which is really nice. Okay, when we talk about Okay, you guys can figure 17.2, finish that on your own. When we look at 17.3, they give us all this information here. Okay, they give us all this information and they want us to figure out how big this clearing is by a helicopter making angle measurements as it goes up, which is a whole lot of variables and stuff, and it looks really confusing. And it's all based on, again, trigonometry, on the opposites and adjacents, which is basically tangent. So this whole problem is another tangent problem. And, okay, so let's just go over some basic trigonometry here. First, I said in the last video that sine and cosine are pretty much defined. One way to define them is by a unit circle, right, where this is 1. And sine tells you the y value. It tells you how far above and below the x-axis you are, and cosine gives you the x value. So y is sine, x is the cosine. It tells you how far left and right you are. So right here, cosine is 1. Here, cosine 0, cosine's -1, cosine 0, cosine's 1 again. Right? It tells you how far this way you are. Sine, here, sine is 0. There's no y, right? Sine is 1. Sine is 0, sine is -1. We want to do stuff in radians, so this is pi over 2, this is pi, this is 3 pi over 2, and then we go back to 0, which is the same as 2 pi, we can go 4 pi. And positive is always this direction. We always go that way. Okay, those are positive angles. If we have an angle here, there's two ways to measure this angle. We could say it's all the way around, so a really big angle, if we want to get this thing, or we can say it's negative the smaller angle. Either one works. It'll give you the same information, give the same things. When it's small like this, it's generally easier to say negative a small angle than this huge angle to get there. And okay, so that's how sine and cosine are defined. Then tangent is another way to define tangent besides opposite over adjacent, is that tangent of an angle is sine over cosine. Is the ratio of sine to cosine, which we said sine is y and cosine is x, which is y over x, which of course is equal to the slope, like we just said. So that's kind of where that comes from. When you get to 90 degrees, the slope is infinite, right? Sine is 1, cosine is 0. We're dividing by 0 because anytime cosine is 0, the slope is infinite. Cosine is 0 right here at 90 degrees, or pi over 2. It's 0 right here. So we have infinite tangent or infinite slope. So that's how, so that's how these things are defined. You can also look at it if we have, let's say we have an angle here, theta. I'm going to put one on that side now. And we can draw a right triangle out of it. So if we do that, I'm going to draw it bigger here. So there's our angle of the circle, and we can make a right triangle out of it. Then this is the y, and this is the x, right? So tangent is y over x, and this is hypotenuse, right? It's special. So the y value here, the sine of that angle is the ratio of the y value to the hypotenuse. Now we're calling the hypotenuse 1, so it didn't matter. But what if the hypotenuse wasn't 1? What if it wasn't the unit circle? Then we have to take that hypotenuse into account. So in general then, sine of an angle is the y value, which is the opposite divided by the hypotenuse. Right? So sine is opposite over hypotenuse. So if the hypotenuse is 1, we don't care. It's just the opposite, like I said here. But if the hypotenuse isn't 1, we have to take into account. So sine is opposite over hypotenuse. Cosine is the adjacent, the x value, divided by the hypotenuse. And then tangent is the 2 divided by sine over cosine, which is opposite over hypotenuse divided by adjacent divided by hypotenuse. And hypotenuses cancel. They're in the bottom, both in the bottom of the bottom. So we just get opposite over adjacent. And people remember SOHCAHTOA and stuff to remember these things. So there's two ways of thinking about these relations. You can think of them as right triangles. With right triangles and opposite over adjacent to the angle and everything. Or you could think of it as the coordinates of a circle. And the unit circle is easy because you don't have to worry about the hypotenuse, it's 1, but it works for any circle. But then you just have to worry that if the hypotenuse isn't 1. Tangent's the same, right? Tangent doesn't care about the hypotenuse because it's the ratio of this side to this side, but sine and cosine do. So, okay, that's the basic idea of sines and cosines. Now, you probably remember that there's the other ones. What if you want the hypotenuse over the opposite, which is sine upside down? So if we put 1 over sine theta, which is what hypotenuse over the opposite, they come up with a name for that. The way I remember it is there's always a co in every pair. Since sine doesn't have a co in it, this must be the one that is left, so that'd be cosecant, they call it, cosecant theta. 1 over cosine has a co in it, so that's the hypotenuse over the adjacent. It's just upside down. And so that would be secant theta. And the one that makes sense is 1 over tangent is cotangent. It seems like they all should be that way, nice and simple. Like there's a tangent and then a cotangent. There's a sine and a cosine. But I didn't make this stuff up. It's messed up. So this would be what? Tangent's opposite over adjacent. So this is adjacent over opposite, which is cotangent theta. These aren't used way as much because if you have one, they're just upside down. Like, what do you really need these for? They can be convenient, and you definitely use them in calculus and stuff, and you should know that that's the way it works. But the most useful ones are sine, cosine, tangent, because if you have those, you have everything you need. These are just those upside down. So, okay. So, we still haven't even touched problem 17.3. This is going to be a long video, I think. All right, so let's actually get to 17.3, which is going to be using these relationships to figure something out. So we have this picture, and I'm just going to be going off of their picture here. I called this Y. So we have a helicopter that's Y distance above the ground. We don't know how far that is. And then it makes some angle measurements of beta, this big angle, then alpha, this small angle. And then it goes up 100 feet and makes another measurement of this big, and thus the Greek letter gamma, and measures that angle. And we want to figure out how big this clearing is so it knows where, if it can land there or something. Okay, so I called this A, and then this called that B, just because you got to call it something to do these problems. So B is what we want to find out, how big the clearing is, and then A is the rest of the base here from the distance a helicopter is from the end is A plus B, and then this is Y. You gotta, that's one thing you always gotta do is put some labels on it. So those are the numbers I chose. Okay, so now we gotta use our trigonometry skills like these helicopter pilots had to do to figure this stuff out. So you just start going at it. Let's see, we have 3 unknowns, right? We don't know A, we don't know B, we don't know Y. And they measured 3 things. They measured this angle, and that angle. That means generally you can figure it out, right? 3 unknowns, 3 things you do know. So we're going to get 3 equations, 3 unknowns, and then we have to solve for the answers for B. Okay, so my voice holds out. Terrible. Let's just start writing down some relationships here. Okay, let's start with this one. Gamma, this angle here, which they tell us what these are. Gamma is 47 degrees. So let's just write here 47 degrees. So tangent of 47 degrees is opposite, which is A plus B, divided by the adjacent, which is 100 plus Y. So that's one relationship we have, right? That's the big triangle here. We look at this gamma, it's the big triangle. This side, the opposite of the angle is A plus B, and this side is 100 plus Y, so that's equal to tangent 47 degrees. And we know what tangent 47 degrees is. That's just a number we can look up. So tangent of 47 degrees equals opposite A plus B, so A plus B divided by the adjacent, which is Y plus 100. And that's just a number we can look up. Okay, that's one relationship that we know. Now let's look at beta, this angle here, Greek letter beta. Tangent of beta, and they say that beta is 54 degrees. So tangent of 54 degrees is this angle here, so its opposite is A plus B also. So opposite over adjacent is Y. So it's also a plus b, same opposite, but it's adjacent, it's just y now. Okay, now we have two equations and three unknowns. We know these are numbers in our calculator, but we don't know a, b, and y. But we know one more thing. We know what alpha is. Now alpha, notice, is not a right triangle. So we can't use tangent or anything. It's this funny triangle here. But we do know this angle here. Okay, let's call that, we haven't used theta yet, let's call that theta. So theta, that angle there, which that is a right triangle, right? That's just beta minus alpha. So theta is beta minus alpha. They're trying to be tricky and not give us the right triangle one, but this is like a SAT problem or something, we can figure it out. Since we know alpha, we know that this one here is the big one minus the small one, beta minus alpha. Let's see, beta is 54 degrees. Alpha, they told us, is 25 degrees. 54 minus 25, let's see, if it's 55, it'd be 30, so 29. So 29 degrees. Okay, so theta here is 29 degrees. Its opposite is A, and its adjacent is Y. So finally we have tangent of 29 degrees is equal to opposite A over Y. A over Y. Okay, now we have three equations and three unknowns. So we can solve it, right? These are all numbers. A, we don't know A, B, and Y, but we have three things we can solve, we can figure it out. This is the simplest equation. So we can try to maybe solve for, we can solve for A here. So A is equal to Y times the tangent of 29 degrees. At some point we're going to put this stuff in our calculator and keep a lot of decimal places, which is going to be a pain. Make sure your calculator's in degree mode. 29 tangent is 0.55430. Okay, I'm going to keep all those. So that's 0.5543y. That's what A is, 0.5543y. Okay, now we can plug that in to these other ones. So let's take the first one, tangent of 47 degrees. 47 is 1.072. Tangent of 45 is 1, because that's when the opposite's equal to the adjacent. It's an isosceles triangle. So we know anything, any number over 45 degrees, we know tangent's bigger than 1. Here we know tangent's bigger than 1, right? Or the slope of an angle bigger than 47 degrees is greater than 1, so that makes sense. So using this first equation here, tangent of 47 is how many decimals? I'll keep 1.072 is equal to A plus B. Wait, I'm going to replace A with 0.5433y. There's no one way to do this again. There's lots of ways to solve three equations and three unknowns, but they're all a lot of work. You just start plugging stuff in. Sometimes you can figure out a clever way to do less work. I'm not figuring that out right now. I'm just going to plug away. So 5543y plus b divided by y plus 100. Okay. Now we only have a y and a b. So we need two equations, and we have this one here. Let's solve for b now, just because we can, and then we can plug b into our last equation. Okay, so that's, again, there's lots of ways to do that. So multiply the y plus 100 times both sides. So that would be 1.072y. 1.072y is y times that, then 100 times that is just two decimal places over, 107.2 equals 0.5543y plus b. We want to solve for b. So b then is this minus that, 1.072 minus 0.5543. So minus 0.5543. I get 0.518, close enough. So we have 0.518y, 1.072 minus that, I think, yep, that looks right, plus 107.2 equals b. So there's our b formula. So let me circle those here. This is our a formula. So I'll put this here, that equals a. This is our b formula. Now we can use this one here, the last one we didn't use, to solve for a. So tangent 54 degrees, 54 tangent is 1.376, close enough. So using this one here, 1.376 is equal to, that's tangent 54 degrees, is equal to a plus b. A is 0.5543y plus b is this, 0.518y plus 107.2 divided by, let's see, we're using this one right here. So tangent 54 degrees, 1.37 is equal to a plus b divided by y. Okay, all we have are y's, so we should be able to figure out what y is. Multiply y times this side. We have 1.376y is equal to all these other, we can add those together now. So what's 0.5543 plus 0.518, 1.0723y plus 107.2. Let's put all the y's over here. 103.76 minus that one. So minus 1.3. I get that we have 0.3037y is equal to 107.2, or finally y is 107.2 divided by 0.3037, which equals 107.2. I get 353. Let's call it 353. So y is 353. That's how high the helicopter was above the air. If we go back to our picture, the helicopter was 353 feet above the air, then went up an additional 100 feet. Okay, so we figured that out. So now we know how high the helicopter was. And now we can figure out the other ones. A is 0.5543y, right, from this formula. So A is 0.5543y, so that's times 353. So times 0.5543, that's 195.6, let's say 195.7, 0.66, something like that. That's our A, and let's see, B is, where is B? B is this thing right here, 0.518y plus 107.2. So B is 0.518 times 353 plus 107.2. And actually, that's what we want. I didn't really need to figure out A, I guess. What we want, I think, is B, right? Because B is the clearing. Okay, so let's figure out, yeah. So we know what A is. A was 195.7, that's interesting. But they want to know how big the clearing is. So we did some extra work. So we get extra credit for that. So how big is a clearing, which is B? So 0.518 times 353, 0.518 times 353 plus 107.2, and I get the clearing is about 290. So about 290, and I think we're dealing with feet. So 290 feet after all that. Okay, so we did a lecture work figuring out A, but it wasn't that hard. So B is 290 feet. So that is how you do this problem. I've seen problems like this on finals and tests, and the trigonometry part's pretty easy, just using ratios. Here it's all tangent. Sometimes it might have been cosine or sine or something, but in this case it was just all tangent worked for us. And then we get 3 equations and 3 unknowns, and you just algebra away. And one of the tricky parts of these problems is always just what to call stuff. You got to label the things you don't know. Give them nice simple letters like Y and A and B, things that kind of make sense to you. And then what we want is B. All right, so that's how you do 17.3. Now there's other ones that are kind of like this, like 17.7. Again, they give you some angles and things. Be careful if they give you the angles in radians. Here I think it's radians, so always be careful with radians and degrees. Make sure your calculator's in the right mode. And then just use trigonometric ratios. Okay, what do we know? You know, and always make right triangles, right? Like this one here is not a right triangle, but the big one is. So make right triangles. Use sines and cosines to relate things. They told us some numbers here. So it's a very similar problem. So I'll let you figure that one out on your own. Some more general stuff in solving the 17 problems, like 17.5. Here you're going around this way, which is right? Counterclockwise is the positive direction to go. Let's say they're going to fool us and we wanted to go clockwise. Then omega would be negative. So we'd have a negative omega, our angular velocity would be negative. Positive direction is counterclockwise just because we decided that would be the case. So if you want to go this way, just the way you include that is you have a negative omega. Omega would be like -3 rotations per minute or -2 radians per second or something. So that's one thing to keep in mind. Remember that 2 pi radians per second is 1 circle per second, because 2 pi radians is a circle. There are 2 pi radians in a circle, like 360 degrees in a circle. So 360 degrees a second is the same as 2 pi radians per second, which is like 60 RPMs, right? 60 rotations per minute is 2 pi radians per second. So just remember to think about radians and stuff. Remember the 3 formulas that we're always going to use. The angle you travel is always omega times time. Be careful the units are right. Seconds, minutes, always got to match the units. Omega should be in radians here. And then the arc length that you travel is the radius times the angle, again theta in radians. That's how far you actually go. And if you want to know the velocity is just omega times r, the angular velocity times the radius. And angular velocity should be in radians per second or something, and then r would be in meters, and you'd have meters per second. You can also find the velocity if you know the circumference, 2 pi r divided by the time for one circle. The time for one circle, you put a big T, because that's the period, the time for one circle, and you can figure that out. So the distance you go, the circular distance divided by the time for one circle. So lots of ways to think about these problems. Always draw good pictures. And the video I made last in 17.1, I went over the coordinates when you go in a circle. So you look at that for these problems too. But they're all variations on this stuff. And you just have to get, again, really good with using radians and drawing circles and thinking about these formulas, and then the positions, sines and cosines in the circle like I went over in the last video. So, okay, hopefully that helps. Good luck solving everything.